Yesterday we did an area of a triangle, right? I didn't mention a triangle that looked like this, but hopefully, I think you had something like this on the homework though, didn't you? We had to find the area of a triangle like this? Yeah. So, if you consider this to be the base of the triangle, then where's the height? Yeah, it's on the outside, isn't it? Actually, it's going to come to here, and if we extend that side out, so that right there would be the height. Why is it the height? Because it's what to the base? Perpendicular to the base. Okay, so that would be your height, and that would be your base. So a triangle, I'll put a little sub t down here. For the area of a triangle is what? It's 1/2 the base times the height. Agreed? All right. So what we're going to do today is another t area, but it's not a triangle. It's something that we've discussed before. Very good. It's a trapezoid, and I think I might have a trapezoid somewhere. Let's do that trapezoid. I don't know. That's right. And I did the other day. I looked up in my CP class. We were doing sine, cosine, and tangent. And I don't think anybody asked me because I don't think they were that interested in it. But I think I asked.
By yourself.
Yeah, basically, I'm just talking to myself. So I was saying about sine, cosine, and tangent. I just started thinking. I was like, where do they come up with these names anyway? And so what did I do that night? I absolutely did. I looked it up. I mean, how hard is it? Come on. It's like, look, when I was a teenager, my dad, I would ask my dad stuff, and he'd say, "Look it up." Well, we had a set of listen. Shh. We had a set of encyclopedias, and I'd have to go to this encyclopedias and then flip through the pages and look it up and stuff like that. If I didn't know the name of a word or how to spell a word, what would he say? Go look it up in the dictionary, and that's what I would have to do. Well, you have a general idea. Okay, people always say that, but you have a general idea. You have a couple of options that you could always try for.
And you think it's an F, but it's actually a PH.
Well, then you try both options. You got to be a little bit smart about it. Well, anyway, here's my story. If I can remember what I was doing. Oh yeah, I looked it up, and I looked up where the sine, cosine, and tangent came from, and I almost regret the fact that I looked it up because it's a lot more complicated. It's not like, well, Joe Smith in 1872 came up. No, it goes way back, and they're not really sure exactly where it comes from, and it comes from some like Latin word with a Greek word and blah blah blah. And there's all kinds. Anybody listening to me? Why is everybody just yapping?
I'm sitting right here looking at you.
Okay, but there's a lot of people that aren't. All right. There's still too much talking. Okay. I get it. So anyway, these do have origins. They don't always know exactly the origins of these words, okay? And usually it's from Latin or Greek or something like that. But it's a good thing to look stuff up, okay? If you wondered, you guys had a good question. Where'd they get the word trapezoid from? I'm not really sure. But it's probably different root words, right? It's root words from other words and that mean certain things. And but I think it is kind of interesting to look stuff up to see what they are. All right, let's talk about this. We said this was a trapezoid. Okay, so trapezoid. So it's a and we know stuff about trapezoid. What's true about a trapezoid? You have exactly one pair of opposite sides that are what?
Parallel.
That are parallel to each other, all right? So we know that about a trapezoid. We've got base angles and all that. We've talked about isosceles trapezoids, but I'm just talking about a regular old trapezoid. But this time, what do you think we're going to do with this trapezoid? Find the what? Find the area of the trapezoid. And what's kind of cool about the trapezoid, it doesn't just start with a letter T, but I'll tell you what, let's make this a little bit smaller because what I'm going to do here, I'm going to run out of space. Let's make it a little bit tinier. Now watch this. If I took, let's do this in a different color. If I took this, well actually, let's see if I can do this. Let me ungroup it, see if it was grouped to begin with. I don't know if it was. Yes, it was. Good. Watch this. If I took this, and I took this side and extended it way up like this. Then I took this side and I extended that up. Look what's going to happen. It's going to make a what? It's going to make a triangle. All right, what kind of? There we go. All right, it's going to make a triangle. All right, so really a trapezoid is almost like a triangle. And he's like, it's not almost like a triangle, but it's kind of like a triangle, isn't it? If I took those two sides and extended them all up, it would kind of make a triangle. Let's go back to the trapezoid. Let's go back to the big trapezoid. There we go. All right, so that's kind of interesting to see that they both start with T and they both kind of resemble a trapezoid, except this is kind of like a triangle that's cut perpendicular, parallel to the base. Think of it. Think you got this and you take a knife or a nice sharp machete or something and cut it perfectly parallel to the base. Yeah, yeah, that's right. We're not going to do that experiment in class with a nice sharp machete, okay? But just pretend, I said pretend, that you cut it parallel to this. So pretend there's another part of the triangle. So really the area of the trapezoid is very, very close to the area of a triangle. We know the area of a triangle is 1/2 the base times the height. But look at this. The triangle only had one base. But how many bases does this trapezoid have? It's got 2 bases, right? And we'll call this B1 for base 1, and we'll call this, take a wild guess, B2 for base 2. All right? So the area of a trapezoid is very, very close to the area of a triangle, except a trapezoid has 2 bases and a triangle only had 1 base, right? Because these 2 sides went up and actually came to a point. That's not really considered the base. So what do you think? With all that said, what do you think could possibly be the area of the trapezoid? It's 1/2, exactly right. Instead of just having the one base, right? Instead of 1/2 the base times the height, what are you going to do with these 2 bases? Add them together. That's right. So it goes after this, right here. So isn't it very, very close to the area of a triangle? Area of a triangle is 1/2 the base times the height. But a trapezoid, think of a trapezoid as kind of like a triangle, except it's got 2 bases. You with me? So they both start with T, which kind of is interesting, right? Is because they kind of have the same formula and they both start with T and all that kind of stuff, all right? So it's 1/2 the sum of the bases times the height, and that's how you find the area of a trapezoid. So we are going to have to memorize a few things, okay? You definitely will. But this is kind of an easy one to memorize because you already have the area of a triangle already memorized, don't you? The area of a trapezoid, if you think of it, what we just did right here, it's pretty easy to memorize. You just take the 2 bases, add them up, all right, and that's your base. And then really, it's the same formula, isn't it? It's 1/2 the base times the height, except we have 2 bases, so we just add those 2 bases together. I don't know how many. I don't have them. I don't have it memorized on how many we have, but we'll have several by the end of this chapter, and depending if we get into the next chapter or not, we'll definitely have some stuff you need to memorize. All right, so. But some of the stuff, I mean, like so far, have you really had to really memorize anything like brand new so far? No. Like area of this chapter right here. I'm talking about this chapter. The area of a what? What do we do? Parallelogram, right. And it's just the base times the height. You already had that memorized for area of a rectangle, didn't you? Except we call it length times width, right? Remember that? So it's just base times height. That's really not anything new to memorize. You already had the area of a triangle memorized before you walked in the door, didn't you? All right, before you even came into this class, you already had the area of a triangle memorized. This is very, very close to the area of a triangle, all right? So this is not much of a stretch to memorize. So has there really been anything really crazy hard to memorize so far? No, I don't think so. All right, but we're gonna have some more. But that's what it takes. Sometimes you just have to learn stuff. All right, so so you're just gonna have to memorize them. All right. Oh, I'm sorry. You're absolutely right. Yeah. Sorry about that. I completely forgot. The height. Yeah, absolutely. What's the height of this? Is it this one? Is it this one? What do you think the height is? Right. That's right. It's perpendicular to the 2 bases. Exactly right. So it's perpendicular to here. Is that the only height? No, I mean you could have taken that from here to here, couldn't you? You follow me? I could have taken this. I could say that was the height. We kind of did that yesterday, didn't we? All right. Or I could say it's the same distance. All right. It's the distance to the 2 bases. Remember how we define the distance? Is the perpendicular distance, right? And so it has to be perpendicular. Don't let me forget to put that in there. So it has to be perpendicular. All right? That's easy. We've already dealt with that before, didn't we? We did that with a parallelogram. So it's the same idea for the height. That would be the height. Okay, let's move on. Let's do another crazy thing. Let's do a rhombus. Remember rhombus? You like rhombi? Alright, I think I got a rhombus up here. I think right there. That would be it. No, this would not be a rhombus because that one looks longer than this one. Remember, rhombus, what has to be true? All four sides have to be equal to each other. Alright, so it's like a square, but it's not. Right. It's a sheared square. That's right. That's absolutely what it is. Hit the shear button on my little program, make a rhombus. Actually, it doesn't, because when you shear a square, it actually makes one side longer than the other side. So I had to be kind of careful when I did this. Yep. Yeah, it does. I'm pretty sure. Let's just see if it does. Okay, so there's a square. All right, and then we'll go to this shear thingy and see what it did. See, this one's definitely longer than that, isn't it? So if I even look, if I made it like 80 degrees, see, it's a little overboard, but you get the idea that it doesn't exactly keep them all the same. It'd be nice if it did, but all right. But this is a rhombus. Now there is a. Let's talk about a couple things. We've dealt with a rhombus before. Do you remember that when we did that whole parallelogram chapter? What did we say was true? Actually, yeah, let's do this. What's true about the diagonals? Are they equal to each other? No, they're not equal to each other. On a rectangle, they're equal to each other. Okay, but how do they form? What do they form here? They're perpendicular. The diagonals are perpendicular on a rhombus. Okay. So, do you see those two diagonals right there? Let's make a different color. Let's make this one. It's too close to orange. Let's make it red. Okay, sorry. We used blue earlier. So watch, this red one we'll call D1 for diagonal 1. Alright? And then we'll call the orange one D2 for diagonal 2. Now, I put the D2 here, but it's talking about the whole entire length of the orange diagonal. You follow me? The red one looks like it's just up top here, but it's the whole entire length of that red diagonal. Everybody got me on that? So now we have a formula for the area because, I mean, this is a parallelogram, isn't it? So if you knew the height from here to here, you could find the area of it. But sometimes they don't give you the height, and there's no way to find the height. Are we listening? Sometimes they don't give you the height of this, because this is a parallelogram. So we could say that the area is the base times the height. But what if there was no way to figure out what the height was? But they did tell you that lengths of the diagonals. If they tell you the lengths of the diagonals, here's your formula. And it's really not that difficult. But it's something that you just have to remember. It's 1/2 again, all right? Now watch, times the product of the two diagonals. It's 1/2 D1, D2. That's all there is to it. It's pretty simple, isn't it? It's not real complicated.
When they're not going to like give you D2, they're just going to give you D1, and then you're going to have to like subtract.
Yeah, I mean, there'll be some way to figure out what the lengths are, okay, if they give you this. Again, there are situations where they give you a parallelogram in a rhombus in this situation where there's no way to find the height. Now, if they told you the height and the base, you wouldn't have to go through this diagonal stuff, would you? But if you didn't know the base and you didn't know the height, but you knew the diagonals, then you could go ahead and use this formula right here. Everybody got that? The same thing holds true with a kite. It's the same exact formula with a kite. So this is a rhombus, but the same exact thing is true about a kite. I think I have a kite pre-drawn. Let me just... Did I? There it is. And I even got the diagonals in there. That's nice. Yeah, it's pretty convenient. And let's make that thicker, and let's make it a little bit bigger. About like that. Alright, what did I say about... And let's ungroup it so I can change the diagonals again. Let's keep it same color situation. What do we use? Red and orange, right? So that one's red and that one's orange. Okay? So what's true about the two diagonals on this one? I shouldn't say that. That was a dumb question. What do you think the area of this? I said it's the same as the area of the rhombus. So it's still 1/2 what? D1, D2. But this time it's a what? What kind of a figure is this? It's a kite. Do you remember what's true about the kite? Remember these two right here are equal to each other. These two angles are equal to each other. These two sides are equal to each other. These two sides are equal. This is being bisected. This angle's being bisected. This one's not being bisected up here, but this one is. Well, you got two triangles. Well, you have a bunch of triangles. So sure, because it's a triangle. Well, this one, and this one will. Right, because it makes a triangle. All right. So anyway, but what do we know? What do we care about right now? We care about the area. How do I find the area of this thing? Okay, I take the two diagonals, the orange one and the red one, I multiply them together, and then I do what to it? Divide by 1/2. Divide by 2. Multiply by 1/2 or divide by 2. Because if I divide by 1/2, that's the same as multiplying by 2. I'm not multiplying by 2, just taking half of it. It's the same formula. Same exact formula for a rhombus and a kite. Okay? Two different figures, but it's the same exact formula. Now that's if you know the diagonals. Okay? Let's say you didn't know the base and the... Because this is not a parallelogram, is it? This kite. It's not a parallelogram, so I can't talk about the base and the height. So I have to go by the diagonals. It's the only formula that I'm aware of for the area of a kite. All right? It's not a trapezoid because a trapezoid has exactly one pair of parallel sides. But look, that and that are not parallel. That and that are not parallel. So it's not even a trapezoid. It's not a parallelogram because a parallelogram, both pairs of opposite sides would have to be parallel. Agreed? But nothing here is parallel on a kite. We good? Yeah. Like this one and this one? Yeah, but they're not parallel. This and this are not parallel to each other. Okay? I believe that would be it. Yeah, I'm looking. There's a nice little review on page 776. Not a review, but yeah, it's like a summary. Good. It's a little summary of all the formulas that we've learned up to this point. Okay, so if you look on the bottom of 776, that might be a nice little place to go to look just to make sure you know all your stuff. Everybody good? All right, let's give you some problems and then that'll be it. Let's see what we're doing. We're right on schedule and everything this week. Good. So it's page 777, 778. Lots of sevens in there. 8 to 21. It's not too bad. And it's section 11.2. All right, have fun with that.